Okay, welcome back. This is our review for summative number 6 in Algebra 2. We have some new concepts here at the beginning of our test that you guys are going to be taking. We're going to be solving exponential equations, logarithmic equations. There's a little section on counting techniques for permutations and combinations. And then there's a repeated section there at the end, so hopefully we get some better scores here. So the first two examples here can both be done using two different methods, but what I was hoping you guys would look at, number 1A and 1B, and see is that we have those common baby bases. However, I'll give you a secondary option in a minute. So we have common baby bases, and that's obviously not the official name of what these are. But the common baby bases ask you to look at the number chart for all the powers, and if you look at the rows and you try to find a row that includes the number 7 and 343, that's the row that has 7 as a base. So 343 is the same thing as 7 to the third power. So that's kind of the question you would set up. You'd say 7 is 2x minus 5. 7 to the 2x minus 5 is the same thing as 7 to the third power. And then because we have the same bases, that means the exponents would have to match for this to equal. So then you set up your little equation of 2x minus 5 equals 3. Of course, you're going to add 5 to both sides. And then at the very end here, you're going to divide by 2. So 2x equals 8. So x equals 4. So that's a nice way to solve that question. However, let's pretend you're not excited about maybe the option of having multiple ways to solve two different questions, because the one right after this, we're not going to be able to use the common base method. So you could draw a big line here, or you could just apply your logarithms. So either natural log or common log. But if you have that same exact question, and I'm not going to be doing 1B, that's going to be left for you to do on your own. We could have done that same question, 7 to the 2x minus 5 power equals 343. So you would apply a logarithm of your choice, either common log or natural log. So you know I like to apply a natural log. And if I were to apply a natural log to this question, nothing cancels. But what it does do is you get to use that power property, that Mario property that we call it, for logarithms. So the 2x minus 5 comes down in front. Use parentheses when there's more than one term like that. And right now it's being multiplied by the natural log of 7, which is just some gross number, right? And then the natural log of 343. Again, a gross number. So then you think about this equation, okay, I'm trying to solve for x. So let's divide by the natural log of 7. And this is where our math is going to match up finally. So right here, your line of algebra is going to say 2x minus 5, and then equals, remember these cancel, and then here when you type this in your calculator, you're going to get the number 3. So boom, look at that. Our math totally is going to match up from here on out. It's just how was, what was the maneuver that you did to get that equation. So if you recognize there's a common base, I would argue that this is the easier method for this question. However, if you're the kind of kid that just doesn't like to have multiple methods going on in your head because it's confusing, then just use the logarithm method. Because when we look at number 2A, this one you have to use the logarithm method. So there's no common base between an e and a 10 or a 10 and a 21. So on both of these questions, you're going to need to apply either a natural log or a common log. Now on both of these questions, I'm not going to do 2B for you, but like 2A here, because we have a base e, that means you're going to be wanting to use a natural logarithm probably on this question. And then over here, because the base is a 10, that means you're going to want to apply the common logarithm because he's base 10. Technically speaking, it doesn't matter, but if you use an appropriate logarithm when it calls for it, you're going to see a lot of cancellation, and that's exciting. So here, I'm going to apply the natural log, which makes me happy, to both sides, of course. So over here on this side, you're going to see some cancellation. So these are going to cancel, but the x minus 7 does drop down. That's not gone. And then natural log of 10 is just something I would have to type on my calculator. So, I don't know, something weird. Make sure you're hitting the right button. That was a natural log we applied. And 2.303. It doesn't say where to round, or does it? Well, whatever. I think it said. Okay. So 2.303 is where they want me to round. And then one final step, we're going to add the 7 to both sides. So x equals 9.303. So that's a cool question because there is a little cancellation, so that's exciting. But there's not always going to be cancellation. And then on top of that, you might have some extra algebra steps to do before you can even consider applying the logarithm. So on these two questions, you're going to need to isolate the base before you begin any logarithm work. And then at this point, you can use a common log or a natural log. And then when I look at both of these questions, I notice the bases, this one has a 5 and this one has a 7. So that's neither logarithm is any better than the other one. So at that point, it's just your choice. So first step, I need to isolate this base component using a little algebra. So I'm going to add 7. My handwriting's a little rough today. All right, 4 times 5 to the x power equals, I can add 32. Now remember, you cannot multiply this 4 and 5 together. This is a thing. You're going to just kind of leave it alone. We're going to divide by 4. So now I have 5 to the x power equals 8. So surely I can't use the baby base method. 5 and 8 do not have any sort of common bases there. I'm going to apply a common log or a natural log and, just let's shake it up. Let's use a common log this time. So using a common log, applying it to both sides of my equation. I'm not going to see any cancellation, but what I am going to see is this exponent's going to come down in front. So now it's x times the common log of 5. If you use natural log, you would just have natural logs for all these. Equals the common log of 8. Again, gross numbers, so we're just going to divide this over. So on my calculator, and make sure you guys are practicing this typing. I know sometimes we do a lot of watch and learn kind of stuff in math, but this one really requires you to practice it. A lot of muscle memory happening here. Log of 8, close that logarithm, divide by log of 5, close that logarithm. I do not have this keyed yet, so I would go ahead and go over here. I used common log this time. I already forgot what I'm typing. All right, 8, okay. So log of 8, close the logarithm, divided by, use the right one, log of 5. You actually don't have to close the second one, but it's a good habit to do it anyways. And I'm going to write down 1.292 because of where they want me to round. Awesome. So you should be getting kind of funky answers on most of these logarithm questions. I'm going to leave 3B for you to do on your own. And we're going to move on to the next section. So these are going to be logarithmic equations, and the big idea is that we're going to be exponentiating. So that's that stuff where you shove a base underneath the problem and hoist it up. So I think some kids get a little confused because on 4A and B, they're like, well, why can't I just say this equals this? Well, technically you can, but I really want you to focus on why you can. To undo a logarithm function, you would have exponentiated with a base that matches the logarithm space. So what you're technically doing is you're shoving a 3 underneath this problem, and you're hoisting these problem pieces up into the exponent position. So I know we're getting a little lazy now in Algebra 2, and we kind of know what's going to happen, so we don't bother rewriting it, but I think it would be really beautiful if you guys wrote down, if you're having a little confusion, if you wrote down, this is now 3 to the power of log base 3 of 9x minus 4 equals, and then again, 3 to the power of, oops, why is that blue? No reason. All right, log base 3 of 3x plus 20. So, yes, definite cancellation here, but I think some of us are to the point where we're not really sure why they cancel until we see it written this way. So yeah, totally, cancels. Cancels. That is not how you spell cancels. Okay, so those are gone, these 3 to the log base 3 components, but then your exponents are still here. They're going to drop down to the main level of the equation. So now you got a nice little algebra equation. 9x minus 4 equals 3x plus 20, and I'm going to need you to solve that. So most of you are going to subtract 3x over yonder, which means you're going to add 4. Now, these questions sometimes do come out really nice. And often they're just if you hit math enter, if they're not looking nice at first, they'll change to a nice fraction, nice rational number. So in this case, you actually have an integer, a whole number. If I can add, right? Let's see, that gives us x equals 4. And we talked about checking for extraneous solutions in our notes. I'm not going to give you any questions on this test where you have to check for extraneous solutions. So no worries on that. Let's look at 5a. So this is why I really wanted you guys to focus on like why you were canceling out the 3 with a log base 3, because this question is not set up that same way. So the first thing you're going to need to do is we're going to have to isolate the logarithm before we worry about any exponentiation. So isolate the log, and then you're going to be able to exponentiate, which I'm just going to abbreviate because it's a hard word to spell. Okay, so exponentiation is not yet. We're going to subtract 4 first. And that gives us log base 6 of x minus 1 equals 2. Come on, pen. And now we're ready to, quote, get rid of the logarithm of base 6. So this is where we're going to exponentiate with the same base that matches the log. So like this is being shoved underneath and we're creating exponents out of the original problem. So I really like when you guys take the time to rewrite this so you really get it. It's 6 to the power of log base 6 of x minus 1 equals, and then 6 to the power of 2. This is so critical, this moment right here. Because while we do have some cancellation right here, you do not have cancellation here. And this is 6 to the second power. This is an exponent now. That is usually where this problem gets messed up, is something weird happens on the right side. So the x minus 1 will drop down. 6 squared is really a 36. So really easy question now. We get x equals 37. But you really have to understand what it means to exponentiate. So, you know, pay careful attention to what you're doing in your algebra, but also, you know, like maybe if your handwriting's sloppy like mine is, take the time to go a little slower and write out the step again. I think that'll help. All right, same idea. We're going to be exponentiating, but not yet. We have to isolate this logarithm first. So, 2 steps to isolate. We're going to need to add the 5. And then on this question, a lot of kids forget to do something with that 4, and that's where their problem is occurring, because they're like, oh, I did something weird with the 4, or I never divided by 4, and I just went ahead and exponentiated, and that's not going to work out. So over here you have a 12, so now you should divide both sides by 4. And now we can talk about exponentiation. So we have the natural log of x minus 2 equals a 3. And then the base, remember the base of a natural logarithm is the number e. So the natural log, another way to write it, is log base e. So if your calculator kind of gives you a gigantic clue, if y'all look at your calculator and you find the natural log button right above it, I know you can't see it too well here, but it says e to the x power. That's because he's the inverse. So I'm going to write down on my paper now what I'm doing. I'm going to exponentiate with that base, which we just discovered was an e. So e to the, and then over here, e to the. So the problem gets shoved up to the exponent. And I'm going to take the time to rewrite the problem. This is now e to the power of the natural log of x minus 2. And then over here, this is now e to the power of 3. Key difference here. A lot of kids think this is e times 3. It's not. So yes, you do have cancellation. And I know it's exciting to just say I have cancellation and not show it, but try. And then x minus 2 will drop down, and this is going to be gross. E to the third power. I don't know. E is a weird number, right? 2.718 something or the other. I like to use this e because it automatically brings up an exponent. If you, oops, that's not what I wanted. Get rid of that. If you use this e, then you have to insert your own caret to raise it up to the exponent. So, second natural log, that would be e to the third power, automatically in an exponent. I need to write down 20.086, because they want to the thousandth. 20.086, and then one final step. Of course, you're going to add 2 to both sides. So 22.086 is our final answer. Anytime an e or a natural log is involved in your problem, it's probably going to have a little funky answer. So be careful. Keep in mind, number 6b here, this is a common logarithm. So when it just says common logarithm, we know that's a base 10 logarithm, right? So keep that in mind and look at your calculator if you feel like you're stuck and you're not sure. Oh, I love this section. I love this whole unit about probability and counting techniques and a little bit of stats work. So let's talk about 2 vocab words. We have permutation and combination. So when we are trying to figure out, how many ways can something be arranged or lined up, those are some keywords for permutation. So if you see or infer the word arrange, line up, order, assign is another word we see a lot. Basically, the idea is that order matters, is what we usually say in math. But what that means is that if you rearrange the order in which I list off my winners, or whatever the case is, that I get a different outcome. So permutations produce lots and lots and lots of ways to do it. Combinations, however, order doesn't matter. So if you think about, things where order does not matter, that would be like selecting for a team. Like, you don't really care if you're selected first, second, or third because you're on the team, so who cares? Oops, come on, pen. Team. This is a little confusing, but the word choose often is associated with combination, so keep that in mind. Committees, anytime there's a committee problem, you just want to be on the committee. Committee is just a fancy word for team, let's be honest. But the big idea is that the order in which you're selected, like, who cares? You just want to be selected. All right, so this question, you have to tell me whether it's a permutation or combination, and then we're going to figure out how to figure out the actual answer. So we're going to arrange 6 students at the door. So that's one of our keywords for a permutation. So that would be your first concept that I would have you understand on the test. And then you're arranging all 6 of them. So on your calculator, you can do this 6 permutations of 6. Another way to do that question, though, because you're arranging all of your people or your things, you could also do 6 factorial, or you could go old school and go 6 times 5 times 4 times 3 times 2 times 1. Cool news, they're all going to give you the same answer. So let's go to our calculator. And on the newer ones, you just have to go straight to the math menu and bring up the permutation. So math, and then go over to the probability sub menu. And then number 2 here says NPR, that's a permutation. So on these newer operating systems, you can just insert the numbers. This one doesn't matter because they're both 6s, but the number that goes here always has to be the total. So keep that in mind when we have a question where it's not all of them. So the larger number, if you want to think of it that way. So 6 permutations of, oops, get back there, 6. Big number, 720 ways. So let's waste our life trying to figure that out, right? 720 ways is your answer. How many ways can you select a team? There's a keyword there, a team of 6 students from a class of 35. So team is keyword. You don't really care what order that you're selected, just that you're on the team. So this is a combination. And when you go on your calculator, the only way for you to get this answer right now, because of the way we've taught you, is you're going to pull up the combination feature. Make sure you put 35 first. So 35 combinations of 6. I have not done this yet, and I don't know these off the top of my head, so here we go. Math menu, probability. This time pull up the combination feature, which is number 3. You can just type number 3. So 35. Was it 6, I hope? Whoa! All right, so that number, 1623160. 1623160. Yikes. Okay. So a lot. And I know that feels like, oh my gosh, that was so many. But if you were to type that in as a permutation, you would have had even more, if you could believe that. So make sure you're pressing the right command, I guess, is the moral of that story. All right, this question, we're making some independent decisions. I mean, I know they technically aren't independent in your mind, but they really are. You have to make 3 decisions. You have to choose an appetizer, an entree, and 4 desserts. So assuming that you like everything, how many meals can you create? So 1 decision, 2 decision, 3 decisions. How many ways can you decide on that first one? I got 5 options. And then on the second one here, we've got 6 options. And then my third decision, I have 4 options. And then this is called multiplication. Well, it's called a fundamental counting principle. And you just multiply them together. It's actually a really easy question if you know what you're doing. Also helps if you know how to multiply. All right, it's 120 ways, so 120 meals. And by no means do I expect you to list out all 120 meals. I just want to know how many you could make. So this is another counting principle question. We're making a schedule, and you have to select a science class. This will say of, I think. All right, so science class, math class, because that's more important, right? No. And then a foreign language class. So we're not worried about like, do you put science before math before foreign language? Just how many different selections can you make? So really it's the same thing as number 9, counting principle again. So 5 science class options, 4 math class options, and then 4 foreign language options. Again, multiplying them together because that's how counting principle works. Let's see, 80 ways. So we'll just call them 80 schedules. Not worried about when you're scheduling them, just 80 different collections of classes. All right. I don't know why I did all those questions for you. Sorry. All right, so this is an old concept. Oh boy, man, some of you really need a better score on this one. So let's capitalize on this last retake here. If you don't get that good score after this one, then you're going to have to retake this on your own for sure. So we have 2 functions. We have function f, which I'm going to kind of highlight here in blue. And then you have function g, which if my pen works, I will highlight in green. There we go. And I want you to do a few things with these functions. So I think some of you got really confused with the notation. This is called function notation. And there's a plus sign between these 2 things. So I know they want me to add something together. They want you to add the functions together, but they also want you to plug in x equals -2. So it's not that just you're adding them. You're also going to tell me that x equals -2 and not leave it as x anymore. So this is totally up to you how you figure it out. For a lot of you, you were very successful when you figured out what f of -2 was, and then you also figured out what g of -2 was, and then you added your answers together. So plugging in -2 for f, if memory serves me correct, I think a few of you were trying to do some really brave mental math, which I love, but you weren't checking it and you were doing some weird order of operations. So like for instance here, you don't do 7 times -2 first. You do -2 squared first. Make this a 4. 7 times 4 is 28. So if you are not sure what to do, then you just type this straight into your calculator. But since some of you are really excited about doing mental math for some reason, I'll do that. We just said this was a 28. This is a plus 10. This is a plus 3. So that's 38 plus 3. Isn't that a 41? So that's the first part of my problem. And now I go and plug in -2 into the g function, which would be 2 times -2 minus 5. I should have given you more space. I apologize. I'm going to work down here. All right, so that's -4 minus 5. So that's -9. And then according to our directions, we're supposed to add them together. So 41 plus -9. I'm a math teacher. I should be able to do this. All right, that's 32. So final answer to that question is 32. If you would rather add the functions together and then plug in -2 at the end of that, that is another acceptable way to do this question. All right. Oh my goodness. This question, f of x minus g of x. I know what happened. It was just a matter of notation. You guys were freaking out because you're like, well, what am I supposed to do with the x? All this means is that you keep your functions as functions. Like you don't plug in anything for x. So basically you're just going to leave x. And I just want you to subtract the functions. So some of you understood that and then still had a mistake. So f of x, the function with x left as x, is 7x squared minus 5x plus 3. And then you're supposed to subtract function g, and then some of you did this, even though I thought I made a big deal about it, and then you got the problem wrong. Well, that's because you aren't subtracting all of g. You have to subtract all of it, guys, including the -5 at the end there. So if you just go ahead and distribute the negative, I think that's the safest way to do this question. 7x squared minus 5x plus 3, and then this is a minus 2x, and then here this would be a plus 10 on the end. And then when you come through and you collect your like terms, which there's not a whole bunch of them, just a couple, these guys get collected, right? So final answer, 7x squared minus 7x plus 13. So I guess number 1, your task on that question is to understand the notation. And then the second issue, and it is a concept error, is that when you subtract a function, you need to distribute the subtraction all the way through that guy. So please start using parentheses, I guess is the request from your teachers. All right, here, the directions have a little dot between them here. So that means you're going to multiply. And they want you to change x out for 2. So this is kind of like this first question where you can do it in either order. You can decide to multiply the functions and then plug in a 2, or you could plug in a 2 to each function and then multiply the answers. I personally prefer the second method where you plug in a 2 first. So plugging in a 2 into function f, and the same issue, some of you were doing order of operations weird, and that was our problem. All right, I can do this, right? Plus 3. So this comes out to, oh boy, we did this one before, 28 minus 10, minus 10 this time. Okay, so that's 30, no, 28 minus 10 is 18, 18 plus 3 is 21. So hold on to that number for a minute. I'm going to also figure out g of 2. Work down here. Man, I really should have given you more space. I'm so sorry. All right, 2 times 2 minus 5. Let's see, that's 4 minus 5, so that's negative 1. And then remember the task was multiply them together. So we have 21, and you're multiplying it by a negative 1. And that's not really rocket science today. Abruzzo, that's negative 21. Sorry, I'm trying to write out really good like slide notes because some of your friends are just looking at the slides, which is fine. All right, this one. My goodness, it's not supposed to be that hard, guys. You're just setting up a division question. So f on the numerator, 7x squared minus 5x plus 3. And then in your denominator, you have g, which is 2x minus 5. So that's actually the answer to the setup. This is it. Cool. This is the question that some of you were having problems with. So for your domain, what you're going to tell me is you're going to take your denominator and you're going to tell me that it can't be 0. So you're going to set up the denominator, which is 2x minus 5, cannot be 0, and figure out what that number is. So you're going to add 5, divide by 2. So x can't be 5 halves, or you can say 2.5. And that's what you write down for domain. X cannot equal 5 halves. You know, I feel like we've done that question a lot, and I think the issue is some of us just are not practicing that. So that should not be a hard question if you practice it. Please, please, please. All right, composition. The composition question, you have to make sure you go in the right order. You have to start on the inside. So you start right there. Find g of 2, which means you plug in 2 in for g. So 2 times 2 minus 5 is negative 1. Then you go to f. So then you take function f and you plug in this negative 1 that you just found. And I'm going to run out of room, of course. All right, so function f was 7 times negative 1 squared minus 5 times negative 1 plus 3. Okay. Again, my friends who are doing some mental math, just make sure you're doing your order of operations properly. You square this first. This is a positive 1 now. 7 plus 5 plus 3. I could do this. That is 12 plus 3 is 15. The final answer you get is your answer. So start on the inside, work your way out to the outer function. That's how you do composition of functions at numbers. Okay, I think that's it. That's all I'm doing on this video. I'm going to post the answer key to the entire thing. I wish you guys luck. You've been doing very well on assessments lately, so keep up the good work and please study, study, study.